Good afternoon. Today we are going to study Engineering Mathematics 3. And in this, we are first with the differential equation, unit number 1. Now, in that differential equation, in this video, we are going to study only complementary function. That is of unit number 1. Now, we have linear differential equation. So, linear differential equation, in this we have higher order linear differential equation with constant coefficients. So means we have this, if we will write it, then we have d to the power n y upon dx to the power n, and it goes, your power goes on reducing a1 d to the power n minus 1 y upon dx to the power n minus 1 plus a2 d to the power n minus 2y upon dx to the power n minus 2. Likewise, we can go plus we have a n y, and that we are going to say d to the power 0. We are reducing, which is 1. We have that y, which is equal to q. So this is higher order linear differential equation with constant coefficient, means we are going to say a1, a2, these are constants. So with constant coefficients. Now if we will write it in symbolic form, then we have in symbolic form, it can be written as, so we can write y, we will take common. So we have d to the power 1 plus, that is d to the power n minus 1, a1 we have, plus a2 d to the power n minus 2 plus dash 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 plus a to the power n, and then we have into y, and that is equal to q. And this d, this we are going to say as d by dx. And likewise, we can write this linear differential equation in symbolic form. Now, to find CF, we are going to write it in auxiliary form. So we have AU, XILIARY, auxiliary equation. Or we can write it as characteristic equation. And in this, we are going to write that d as m, so m to the power n plus a1 m to the power n minus 1 plus a2 a to the power n minus 2, likewise plus an, and that is equal to 0. And by using this, we are going to find actually complementary function. Now, what is complementary function? So we have solution of differential equation. Solution of differential equation is equal to CF plus PI. CF we have complementary function which we are going to study in this video, and PI we have this as particular integral. particular integral. Now, this complementary function we are going to find in by using this auxiliary equation, and particular integral we are going to find using this right hand part, which is q. So q is responsible for particular integral and auxiliary equation is responsible for complementary function. So now in this video we are interested only with complementary function, and in next video we will go with particular integral. Now we will have complementary function. Complementary function. Complementary function. So now see, we have already seen while going for this complementary function, we have to use auxiliary equation, which is in the form m to the power n plus m, and a when we have m to the power n minus 1 plus a2 m to the power n minus 2 plus dash 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 plus an, and always equal to 0. We are not going to consider q part because q is responsible for particular integral and we are finding auxiliary equation. Now we will say this as equation 1. Now solving this equation, solving equation 1, we get n roots. We get n roots. Now see, if I will consider a equation with 2 degree, m square minus 2m plus 2 equal to 0, then we are going to get 2 roots. If I will say m cube minus 4m square plus m equal to 0, so we will get 3 roots. So whatever higher order we have that much number of roots over there. Here we have higher order n, so we are going to get roots, that is n roots for equation 1. Now we have 3 cases to find complementary function. Now we will go with case 1. Now in this case 1, whatever roots we are going to get, so roots are real and equivalent. So roots are, real and roots are real and distinct. Real and distinct. And if we are in this fashion, then we are going to write complementary function that is equal to C1 e raised to m1x plus C2 e raised to m2x plus m2x plus dash 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 Cn e raised to m and x. So we will be with complementary function when we have roots are real and equal. Now how we are going to get this equation, or which type of equation we have, then I will take a simple example. Let us we have m square minus 6m plus 9 equal to 0. Now if we will see this, we have m square minus, see here, if you will go with this, then you are going to get this m minus 3 and whole square where we are. Now if I will solve this, then we have m minus 3 whole square equal to 0, and then we will get m minus 3 equal to 0 and m minus 3 equal to 0. And then we will have m values 3, 3. So these are not distinct. Not distinct. And if these are not distinct, then we cannot use this. So for such a type of equations, we do not have this equation. Then this is for, so I can write m square minus 3m plus 2 equal to 0. Then what I will get? I will get m square minus 2m minus m plus 2 equal to 0. Means we have 2 and we have two factors. One will be minus 2, other will be minus 1. Multiplication of these two is plus, and addition of these two is minus 3. And now if you will solve this, then we have m in bracket m minus 2 minus 1 in bracket m minus 2 equal to 0. And we will get two factors, m minus 2, m minus 1, and from this we will get m is equal to 2, and then we have m is equal to 1. So we have these two are real and distinct, which is our case number 1. So try to understand, here we have real but not distinct, and therefore we cannot use for this function. So for this we can go for this. Then what complementary function we will get in this case? So we have complementary function equal to c1 e raised to, now m1 value we have 1, so we have e raised to x plus c2 e raised to m2 value is 2, so 2x, and this is our complementary function. So you have to keep in mind my roots should be real and distinct, then I can write in this fashion. Now we have case 2. Now in case 2, as we have seen in last example, that roots are real and equal. Roots are real and equal. Now in this we have complementary function equal to c1 plus c2x into e raised to mx plus c3 e raised to m3x plus dash 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 plus cn e raised to mnx. Now you have to keep in mind in this, here we do not have m1, m2 because I have m1 is equal to m2 is equal to m. So C1 we have over here, C2 we have over here. So C1 plus C2x e raised to mx. So as 1 and 2 are already considered, m1 and m2. So next term we have C3 e m3x. Now as I have shown you last example, so we have auxiliary equation. If we will consider m square minus 6m plus 9 equal to 0. So simply we have m minus 3 whole square. So if we will solve this, we have 9 and we should have addition should be minus 6 and multiplication should be 9. And then from this we can solve this. So we will get it as, if I will write it m square minus 3m plus 9 equal to 0. And from this we will get m in bracket m minus 3 in bracket m minus 3 equal to 0, and that will give us m minus 3 equal to 0. And from this we will get m equal to 3 and 3. And these are now roots are real and equal. And whenever we have roots as real and equal, then I will get it as complementary function equal to c1 plus c2x, and that is into e raised to 3x. So whenever we have real and equal, then we are going to be in this fashion. So this is case 2 where we have roots are real and equal. Then we have case 3. Case 3, roots are imaginary. Case 3, we have roots are imaginary. Imaginary. And then in this case, we are going to get complementary function that is equal to e raised to alpha x in bracket c1 cos beta x plus c2 sine beta x. So now if I will consider one auxiliary equation, and then in this case we have d square minus d plus 3 equal to 0. So we have this equation, then we cannot have roots for this, and in this case we have to use, that is, this is d actually we have used. In auxiliary equation, we have to use it as m actually. So plus 3, you can use d also, that doesn't matter. And then from this I will get m is equal to minus b plus minus root of b square minus 4ac upon 2a. And from this I will get, here we have value of a, which is coefficient of m square, that is 1. B we have coefficient of m, which is minus 1. And then we have c as constant. And if we will solve this, then we have minus of minus 1 plus in root b square, we have minus 1 square, then minus 4, a we have 1, c we have 3 upon 2 into 1. And then if we will solve this, then we have 1, this is plus minus, so 1 plus minus root of, we have this will be 1 minus 12. So we will have minus 11, and that is upon 2. And from this we will get equal to, as it is minus, so we have I value over there. So we have 1 plus minus I root 11 upon 12. And then if we will separate it, we have two parts. This is a real part. And then we have plus minus I root 11 upon 2. This we have imaginary part. So we have a real and imaginary part. So when we will write complementary function equation, then this part we have as a real part, and this part we have imaginary part. And therefore we will get CF. Here we have real part 1 by 2. So we will get it as e to the power 1 by 2x, and in bracket we have C1 cos beta x, we have to take imaginary. So C1 cos of root 11 by 2 x plus C2 sine of root 11 by 2x. And this is my complementary function. That is when we have roots are imaginary. So real part will be the power of e, and imaginary part we have to take inside, which will be cos and sine. Now in this we can have, if roots are, this is again roots are real and distinct. If we have roots are equal, sorry, when we have roots are equal, then we have to use same C1 plus C2x, and then we have to solve this. So we will see when we will go with this one. So these are the three most important cases to calculate complementary function. So first we will solve the problems which are only from complementary function. Once we are been good with complementary function, then we will go with in a particular integral. So now we will stop here only. Thank you.